Welcome back, Algebra 1 students. We are on Lesson 5 of Unit 1. And in this lesson, we're going to be talking about square roots and finally the real number system. So our learning targets for you for this lesson, you should be able to classify real numbers when we're done and to evaluate expressions that have square roots in them. So we're going to start off talking about the real number system, okay? And I know you've talked about this in middle school and in your younger years. So we're going to start off with the very first number system that you learned about as a child is called the natural numbers. When you were a baby and you had your very first birthday, you learned about the number 1, and then you had another birthday and you knew about the number 2, and so on and so forth. So the natural numbers are our counting numbers. Those are the ones you naturally learn as you're just a child. Okay, 1, 2, 3, 4, 5 on to infinity. You get a little bit older and we added what the whole number system is. We just added one number to that and we added the concept of 0. So maybe you got a sibling and they took your toy away. Now you know that you don't have a toy. You have nothing. Okay, so natural numbers to whole numbers. And then we added, as you get a little bit older, maybe you had a bank account or something, and you learned about negative numbers. So the integers are the natural numbers, the whole number 0, and the negative numbers. Okay, that's called the integers, all of those together. Well, then you got a little bit older and you had a number line, and you started to learn that, hey, there's numbers in between these numbers. There's numbers in between 1 and 2 and 2 and 3. There's decimals in there. There's fractions in there. And we have what's called the rational number system. The rational numbers are any numbers that can be represented as fractions. They include decimals as well, because all of these fractions can also be written as a decimal. Includes repeating decimals, so like 1/3 is really 0.33333 and it goes on forever. So repeating decimals and terminating decimals are also in there. And then we have one more system all by itself called the irrationals. Now the irrationals are none of these at all, okay? Irrationals are really different, and those are things that can't be written as a fraction, okay? So things like pi, okay, pi is an irrational number. It's a decimal that does not repeat. So any decimal that does not ever repeat is an irrational number because it can't be written as a fraction. Any square roots that can't be simplified, so when these are prime numbers under the radical, those are also irrational. All of those together give us the real number system. So there you go. Now you know what a real number is. So one of the things I wanted to do was go ahead and include a slide that has all of that in words. I know it's easier to understand from a picture, but then also I wanted to give you a slide that just says in words what I meant, especially for the rationals and irrationals. Rationals are fractions, terminating and repeating decimals, things like 1/3, 1.1 repeating, that little bar got moved over a little bit. Irrational numbers, pi, square root of 3. In Algebra 2, you'll learn about the letter E, which is a natural log, the base of the natural log. So let's move right along. Let's do some practice here. One of our learning targets is to be able to classify real numbers. So what I want you to do in this example is for each of these numbers identify all the subsets of real numbers to which the number belongs. So first off, I would start at the biggest one, the real numbers. Okay, all of these are going to be real numbers, right? Because we don't know about anything else. So 9 is a real number. Is it irrational? It's not irrational, right? So we don't get that one. Is it rational? Can we write it as a fraction? Well, yes, we can. We can write it as 18 divided by 2 or 27 over 3. Those are all ways of writing 9. So it is rational. Is it an integer? Well, yes, it is. It is an integer. So we're going to give it that title as well. It's a whole number, okay, and it's a natural number. It's one of those natural numbers. When you turn 9, you certainly knew about that number. How about letter B? Is it a real number? It's a real number, okay. Is it irrational? Can I simplify the 3 under the radical? The answer is no. So it is irrational because it doesn't simplify. If it's irrational, it can't be rational. It's one or the other. And if it's irrational, then it's none of the rest of these, right? The irrationals are out by themselves. Letter C is just a fraction. It's definitely real. Is it irrational? No, it is not. Is it rational? Yes, it's a fraction, right? So it's rational. Is it an integer? Well, no, it's not. It's one of those that's in between 0 and 1. So it's not an integer, it's not a whole number, and it's not a natural number. So it's real and rational. In this example, we want to identify just a single set of numbers, a single subset of numbers that describes the situation. So first of all, the cost of an item at a store. If you go buy something at the store, so you have some dollars and some change, you're going to have some tax, what kind of a number would that represent? So a decimal number, it's a terminating decimal, right? If you pay $1.50 for something, whatever it is, although it could be a natural number, more than likely when you add your tax, it's going to be rational. The number of points that a team scores in a football game, well, we're not going to have any negatives in there, right? Could be 0. So I'm going to assume, though, that you actually score points. So let's take 0 out. So this is going to be a natural number, unless there's no score, okay? And the last one is the surface area of a sphere, where the radius is a rational number. The formula for the surface area of a sphere, in case you don't know, is 4 pi r squared. Now if r is rational, that means this is a fraction. We have this pi thing in here. What kind of number was pi? Pi was irrational, so it's still going to be in our number. So this will be an irrational number. Excuse me. So square roots and perfect squares. So when you have a number that's multiplied by itself and they form a product, the number before you square it is called a square root of the number that is squared, of the product. So when we square a number and find a square root, those are inverse operations and they undo each other. It's kind of like when you multiply by 3 and then divide by 3. Multiplication and division undo each other. It's like doing nothing, right? And every positive real number has 2 square roots. So the number 25 has 2 square roots. One of them is 5, because 5 times 5 is 25. But the other one is negative 5 times negative 5 is also 25. So whenever you see just the square root of 25, we call that the principal square root. And it always means the positive value. Okay, so this one, actually I'm going to move that arrow just a second. This one actually means, right here, if there's no negative with it, you only want the positive value. That's called the principal square root, and it's always positive, okay? If you want the negative value, they will write it this way, okay? Until we get to Algebra 2, and then we're going to mix that up a little bit. But for now, for all of Algebra 1, that's how it'll be written to get the positive or negative value. A perfect square, hopefully you recognize some of those, is a number whose positive square root is a whole number. So 0 squared is 0, 1 squared is 1, 2 squared 4, 3 squared, and so on and so forth. So all of those numbers in the top row, okay, all of these guys, I'm going to do this in yellow, all of these are perfect squares, right? If I can do this straight, it's a challenge, right? So let's do some practice, see what we can come up with here. It says, find the square root of a number that is not a perfect square can be approximated using a calculator. So if you get a square root that's not a perfect square, we're going to use a calculator to approximate it. Okay? So the square root of 16, there's no negative with it, so that's just 4. Square root of negative 9, well, we're going to have a negative answer. That one's a negative 3. Square root of 12, this is the one that you're going to go ahead and punch in your calculator. And that one should give you, it's 3.46. So let's just round to the nearest tenth. Let's call it 3.5, okay? And we'll use these funny squiggly lines. That means it's approximately equal to 3.5. Now the square root of a fraction, both of these are perfect squares. So if you take the square root of each one, the square root of 25 is 5, and the square root of 81 is 9. So the square root of the fraction is this, it's 5/9. Number 4 says to find the side length for the square and round to the nearest tenth. Well, the area of a square, hopefully you know this, is s squared. So if I want to find the side length, I need to take the square root of the side squared, right? So I know that 169 is the area is equal to c squared. So if I take the square root of this and the square root of this, square root and square undo each other, so I just get c, right? This is kind of solving an equation. What's the square root of 169? That one is 13, in case you didn't know it. Over on the other side, we know the area is 34. So we're going to take the square root of 34. And let's see. Didn't do that one in advance. Looks like about 5.8. So use your little approximation symbol. About 5.8 inches. That's it for this video. I'll see you next time.